Example 5. Find the limit A, limit e power of 3x minus e power of negative 3x over e power of 3x plus e power of negative 3x as x approaches positive infinity. And the part B have the same function, and the difference is where the limit approaches to negative infinity. So to solve this question, we go to the part A first. Step 1. Understand the problem. In this part A, we need to evaluate the limit of exponential function. Limit e power of 3x minus e power of negative 3x over e power of 3x plus e power of negative 3x as x approaches positive infinity. Step 2. Devise a plan. We need to divide each term in the numerator and denominator by the highest power of e that occurs in the denominator, namely e power of 3x. When we see at this function of the limit, the highest power of e that occurs in the denominator is e power of 3x. So, we divide each term by e power of 3x at the step 3 where we must carry out the plan. So we rewrite the question for the part A and we divide each term by e power of 3x. We simplify the limit and we get 1 minus 1 over e power of 6x over 1 plus 1 over e power of 6x. So, for the next step, we write the limit as x approaches positive infinity at the numerator and the denominator, where the limit of quotient is the quotient of the limit. And then we separate each term of the limit, where we can get limit 1 as x approaches positive infinity minus limit 1 over e power of 6x as x approaches positive infinity over limit 1 as x approaches positive infinity plus limit 1 over e power of 6x as x approaches positive infinity. So, we move the constant through a limit symbol and we can get 1 minus limit x approaches positive infinity, and the function is 1 over e power of 6x over 1 plus limit 1 over e power of 6x as x approaches positive infinity. And we got the final answer is equal to 1. And to check the answer in step 4, we can check by geometrically by plotting graph of the function using Desmos or graphing calculator application. And when we use this application, we can get the graph of the function. And by refer for this graph, we can see that as x approaches positive infinity, the value of fx get closer to 1. Okay, it's closer to 1. So it is same with the answer that we got above or just now. Hence, prove that limit of the function as x approaches positive infinity is equal to 1. For the part B, for step 1, we need to understand the problem, where we need to evaluate the limit of exponential function as the limit of the function x approaches negative infinity. Step 2, devise a plan. To solve this problem, we need to simplify the function first by factoring out the common term in the function. After that, we can proceed as usual to solve this limit of the function. Next, we carry out the plan. Okay, we rewrite the limit of the function, and for the second step, for carry out the plan, we factor out the common term, which is e power of negative 3x. Okay, we can get like this, and then we cancel out the common term e power of negative 3x. We can get limit e power of 6x minus 1 over e power of 6x plus 1 as x approaches negative infinity. And the limit of quotient is the quotient of the limits. And then we separate the limit, we separate each term by its limit, and we get limit e power of 6x as x approaches negative infinity minus limit 1 as x approaches negative infinity over limit e power of 6x as x approaches negative infinity plus limit 1 as x approaches negative infinity. And then a constant can be moved through a limit symbol. So we can get limit e power of 6x as x approaches negative infinity minus 1 over limit e power of 6x as x approaches negative infinity plus 1. And then we got the final answer is equal to negative 1. So this is the answer for this part. For the step 4, we can check the answer geometrically by plotting graph of the function using Desmos or graphing calculator application. Okay, this is the graph of the function, and we can see that as x approaches negative infinity, the value of fx gets closer to negative 1. This negative 1. Okay. So it's the same like we got just now, and it proves that limit of the function as x approaches negative infinity is equal to negative 1.